It says f is a function. These are the notations you need to know. So this is just a regular function right here. Excuse me. This is just a regular function, right? And then this one right here is an inverse function. They're not always going to be functions. Sometimes we can just call them relations. So this is the first relation. This is the inverse of the relation. The way you can identify inverses is that you're going to switch the domain and range. And so when we say range, a domain first is x's and ranges is y. Another thing that I want to talk about with inverse functions is that they have symmetry with the identity. And the identity is y equals x. This is again on page 19 of your functions. I would suggest that you just keep that page available to you when you're taking a test. Okay, so inverse functions identify one-to-one functions. Another way to write or communicate one-to-one functions is with this one-to-one. So it basically says that for A and B in the domain of F, if A does not equal B, then they're equivalent. For every A, there's going to be for an individual A, there's going to be an individual B. And we can see that displayed. I kind of highlighted it here. We can see that displayed in this set of functions. So let's talk about this. It is right here that we know our function is not one-to-one because I have the same y but a different x. So this is a fail of one-to-one because we have the same y with a different x. So the objective here is that this is a fail. This is not one-to-one. So then number 2, you have domain and range. We are not switching domain and range yet for inverse functions. We're just trying to determine if it's one-to-one. Another way of doing this, again, is you don't want the same y to go to a different x. You want one y to one x. So let's see how this works out. So Batman goes to, right? So these right here are your vigilantes, and then these are going to be like your troublemakers. So your Batman is going to go to Joker. Green Lantern goes to that. I don't know how to say that. Wolverine goes to Sabretooth. So we do not have any duplicate. So let's highlight it just to make sure. I do not see any of these lines going to more than one y, and I do not see the y going to a different x. So this is an example of a pass of one-to-one. Another way to communicate one-to-one is called the horizontal line test. So please recall that a horizontal line is flat, right? It goes from left to right. So let's talk about a horizontal line. This right here is a pass. This means 1, 2, 1. When you have only one point on the horizontal line. So that's a pass. Now this is an example of a fail. If I have my horizontal line down here and I have this point on the line, this point on the line, as long as it's more than 1 point, this is going to be a fail of one-to-one. because this is going to be a fail of the horizontal line test, okay? So if we look at number 3, we're going to draw horizontal lines. Let's keep that color. Right here on 4, it passes on 3, passes on 2, passes on 1. Passes at -1, passes at -2. What I want to illustrate here is, if at any point here I had an additional point, right? It doesn't matter how many horizontal lines I have. If any of these lines had more than 1 point, that would have been a fail. But in this case, I only have 1 point on each line. So this relation is 1-to-1. So this is a pass. We're going to call horizontal line test the HLT. So it's a pass of the horizontal line test, which implies that this is 1-to-1. Okay, so let's look at, this was misnumbered. Number 4. Let's see. Number 4. If at any point it touches or crosses a horizontal line, then this is going to be a fail. So if you look at that first line that I drew, my function here touched that line 3 times. But let's say you didn't use that line. You used a line somewhere in the middle. Well, look at this line. 1, 2, 3, 4, 5, 6, 7 times. So this is going to be a fail of the HLT. So this is not 1-to-1. Then you have this, that's a cube root function. So let's look at what this becomes. Horizontal line here. Right now that's a pass. Horizontal line, right, maybe on the x-axis. Right now that only has 1 point. Let's draw these points a different color. And then, let's see, down here maybe. Right now this is all pass. So just by observing this, we can say that this is a pass of the HLT. And just horizontal line test. And this is 1-to-1. Okay. Now, number 6 and 7, it says use a definition of 1-to-1 to determine if the function is 1-to-1. You are substituting A on the left and right and B on the right. So A goes to the left and B goes to the right. You're writing this equation twice. So 1 on the left and 1 on the right. And once you do that, A is going to go for the X and the B is, the B is going to go for the X on the right. So A is on the left, B is on the right. It ends up being 3A plus 2 equals 3B plus 2. I'll rewrite those letters. It's important that you decide what you want to solve for. You can solve for A, you can solve for B, but you know that it's 1-to-1 when your answer is A equals B. This means 1-to-1. Okay, when the A equals B. When I can get A by itself on the left and B by itself on the right. Doesn't matter what side you start on. Doesn't matter what you solve for. It's always going to come down to 1A and 1B. So I'm going to start on the right. We're going to subtract 2 from both sides. 3A equals 3B. Divide both sides by 3. A equals B. So because of the definition of 1-to-1, right? So this is 1, 2, 1 because of the definition. Number 7. Number 7 is tricky. Here's what I would like you to remember. If I take the square root of b squared, I'm going to get plus and minus b. Whenever you take the square root of a variable, you're going to get 2 solutions. If I were to take the square root of a squared, I'm going to get plus and minus a. So we're going to mimic what we did on the left, solving for a variable, just not the steps. So to set this up, it's going to be 3x squared equals 3x squared. A is going to go on the left and B is going to go on the right. So then I have 3a squared equals 3b squared. It does not matter what you're solving for, as long as your end result is a equals b. If it's not, then it's not 1-to-1. So divide both sides by 3. A squared equals b squared. Take the square root of both sides because the square root will undo a perfect square. Now, in this case, we're going to say a equals plus and minus b. If you notice, these are both positive. So this is a positive a equals a positive b. This gives me 2 solutions, a negative b and a negative and a positive b. So because of this scenario, this is not 1-to-1. Okay? It has to be, it has to have a direct equivalent. Positive, positive. This one has a equaling 2 different solutions. So it's not 1-to-1. When you show your work, this is what they're asking you to do on the test. Functions 1-to-1 if given, determine the graphs are inverse to each other. Okay, so here's what you're going to do. You're going to choose a few points and then switch. So remember that inverse, switch, domain and range. They also have symmetry with the identity function of y equals x. And this is page 19 of your workbook. The notation is also for inverse, f of raised to negative 1. So you have f of x, then you have some points. So it does matter the graph. We got to determine which one is which. I'm going to graph this for you. So this is going to be 2 plus 1 over 2x. So when we look at our graph, it's the blue one, not the red one. So this is my graph of f. This is my graph of the inverse. So what you're going to do is you're going to make a table of points. So a table of f, a table of inverse points. Alright, so I have an x and a y. I have an x and a y. Let's go ahead and pick some points. So right here, I have -4, 0. You want to pick some points that are like exact values. You know they're exact values when they go through like a cross like that. See how it goes through like right there? That's an exact value. You don't want to pick something like right here because those are all estimates. Let's pick another point here. So this is going to be -2, 1. And we'll pick another point here. This is going to be 0, 2. So we have -4, 0, -2, 1, and 0, 2. So what I mean by switching x's and y's is that this is going to be my x column and this is going to be my y column. So in the inverse, my y's become x's and my x's become y's. So 0, -4, 1, -2, and 2, 0. We're going to look for those functions. This is the blue graph. This is the red graph. We're going to look for those points on this line right here. Mark the inverse. So let's zoom in. Do I have 0, -4? Yes, right here. 0, -4. So that one checks out. Do I have 1, -2? Yes, right here. 1, -2. That checks out. And then do I have 2, 0? Yes, I do. 2, 0. So it says, again in the instructions, a one-to-one function is given to determine if two graphs are inverses of each other. So yes, these are one-to-one. Yes, 1, 2, 1, and inverses. That's the answer. Now, we can also tell that they're inverses based on symmetry of the identity function. Here's what that means. It means that we take a line that's going to go right here. And it creates like a mirror image of these graphs. So I have the same amount of space I have from the identity function from the f, and have the same amount of space that I do from the identity function for the inverse of f. So that black line there is the y equals x. Again, this is the identity function. Okay, so this is going to be the symmetry right here, or all inverses. This graph is a little bit more complicated. I'm not going to look at these curves. I'm going to look at the upper and lower. So I'm going to look in the second quadrant and the fourth quadrant. So this is the f, this is the inverse. So then we just look for a couple points. Just pick those two. So I get -4, 4, the f, -4, 4, and then the other one was -2, 6. The inverse right? So what we did earlier, we said this is the x and this is the y. So the y's become x's, x's become y's. So the inverse of the first function or the first point is going to be 4, negative 4. The second one would be 6, negative 2. So let's see if we are able to locate that down here on the red graph. So this is blue, this is red. So do I have 4, negative 4? 1, 2, 3, 4. 1, 2, 3, 4. So again, this is 4, negative 4. And then do I have 6, negative 2? 1, 2, 3, 4, 5, 6. 1, 2. So 6, comma, negative 2. And these two are inverses of each other. So what did we say earlier? Yes, 1-to-1 and inverses. Yes, 1-to-1 and inverses. The inverse function. So this is showing you the identity. That's what this is. Y equals X. This is going to be the F, and then on the other side of the identity, you're going to graph the inverse. So the first thing we're going to do is use a different color. This is the F. These are the ordered pairs. And then the inverse will be marked in red. And we'll use those order pairs. So when we read these, we're going to get negative 4, comma, negative 2, negative 3, comma, 1, negative 1, comma, 2, 1, comma, 4. Oops. 4, negative 2, negative 3, 1, negative 1, 2, 1, 4. So that means we're going to plot negative 2, negative 4, 1, negative 3, 2, negative 1, 4, 1. So negative 2, negative 4 in red. And we're going to connect the dots. And then 1, negative 3, 2, negative 1, 4, 1. So then we connect the dots. It's not perfect. This is a sketch, right? But you've created the inverse. So what you're doing is you're switching domain and range. Or switch X and Y. Mark the points. And connect the dots. All right. This one is asking us to give you domain and range. I can give you domain and range so you can see how it works. So for the blue one, we have domain and range. Domain is going to be negative 4 to 1. And they're included. Negative 4 to 1. And then my range is going to be negative 2 to 4. And then the domain and range for my inverse, the domain is, what is it? What is that? Oh, negative 2. It's included. Negative 2 to 4. And then the range is going to be from negative 4 to 1. -4. So domain and range switch, right? So this is just telling you to find domain and range. So you just switch domain and range again. So you're gonna switch domain and range. Okay. So everyone understood that, right? First one. The graph of f of x is given, so this is going to be the f. This is f. So this is all f, and then this is the inverse. I'm going to go ahead and plot the points, though, because that's what we've been talking about. So the points I'm going to use, the f points, are going to be 0, 4. That's a good one. 1, 3, and then 2, 0. 0, 4, 1, 3, 2, 0. And then the inverse points 4, 0, 3, 1, 2, 0, 2. So 4, 0, 3, 1, 0, 2. I'm going to connect the dots. Just a sketch. And 4, 0. So then we're going to talk about domain range. It's going to be more apparent now that you have a graph. And remember, these are included, so they're going to have brackets. So domain is from left to right. Domain of f is going to be 0 to 2. Range is going to be 0 to 4. Then domain of f, this is of inverse of f, is going to be 0 to 4. Then the range is going to be 0 to 2. Right, so they switch.